Good morning and welcome. This is Andre Restaino. I'm presenting today on securing the supply chain using the ISASecure certification scheme for commercial off-the-shelf industrial automation and control systems. Just a little bit of an administrative items here. Because of the large number of folks on the call, like others, this is muted, so we can't hear you. We will record this webinar, and it will be posted on the ISASecure website by tomorrow, so if you want to view it again, it'll be there. If you want to answer questions, you can see in the top right-hand corner of the control panel, there's a little down arrow. So you click on that and take the first button that says Q&A. So what I'm going to try to do is get through the presentation and slide deck in a timely manner to allow more time for Q&A. We're slotted for an hour. If I can finish earlier and give you back some time, that will be great. Okay. So we'll talk a little bit about the Institute, 62443 standards and structure, the ISASecure scheme, and the certifications, and then a roadmap. So the ISA Security Compliance Institute is a 501c6 not-for-profit. It's a conformity assessment subsidiary of International Society of Automation. We operate as an industry consortia with a governing board and members. The governing board sets the strategy and direction and provides oversight for the operations and direction of the program. This year, the board chairman is Ed Crawford from Chevron. We have Vice Chairman Johan Nye from ExxonMobil. Other board members include individuals from Honeywell and Schneider, and we have a liaison, formal liaison to the ISA 99 committee where the 62443 standards are being developed. And the liaison provides some input to ensure that our conformity assessment scheme is aligning with the standards properly. And it's also our conduit for donating any of our work products. So our commitment is to stay aligned with the 62443 standards, and as we develop work products, certification specifications, we donate them to the ISA 99 committee for input into the committee process. The list of our member companies, we have strategic members who are on the board, and then other categories of membership, technical, government, associate memberships, and then informational. We're pretty well represented by the oil and gas industry, Chevron, Aramco Services, ExxonMobil, for instance. So the question is, why certify commercial off-the-shelf products? So our goal is to ensure that security capabilities are independently assessed and they're certified by experts at accredited labs. And for owner-operators, it reduces the effort for an end user to validate and verify security capabilities. So the ISASecure logo on products and listing on our website is significant. The security capabilities are assessed by the independent labs, and they're done to a level 1, 2, 3. We use objective metrics for security capabilities based on industry standards. So most of you know that the 99 committee developing the standards is comprised of subject matter experts. So in the standards are codified hundreds of years of expertise from hundreds of committee participants. So when I get into these discussions, it's important to recognize where we are and how this fits in with the overall cybersecurity risk reduction process. So the 62443 standards uses a life cycle approach to secure and control systems. At the front end of the life cycle, suppliers design and manufacture the COTS control systems. These are not site engineered. These are the off-the-shelf systems and components. Then the integrators engineer and integrate the COTS system into site-specific solutions, which are deployed and operated by asset owners. Many times, the asset owners will use third parties to partner with to do maintenance and support of these systems. You see the arrows making the connections going through the life cycle, indicating the shared responsibilities between the parties, and also the arrows coming back down. So as new threats are identified or maybe a security vulnerability is identified, that's communicated back through the integrators and to the suppliers to triage what the issue is. Is it a process issue at the operational site? Is it a personnel competency issue at the operator site, or is it a product issue that needs to be addressed by the supplier, or a deployment issue as part of the integration project? So the 62443 standards, there are 13 of them. They're designed and structured to address different audiences. At the top, you have the general terms, terminology, the concepts like zones and conduits, et cetera, security levels. Then to the next level down, the green bar addresses owner-operator interest areas like requirements for an IEC security management system, implementing one. Then also the 62443 2-4 standard over on the right addresses requirements for solution suppliers or integrators. So the areas that are more address the technical dimension of control systems are the bottom two rows. The lowest row addresses requirements for components. The next level up is requirements for control systems, and it includes discussions and standards for security levels for zones and conduits. A better way to look at these standards is to organize it into roles. So again, at the bottom, product supplier designs the off-the-shelf product for its intended use, and using a security life cycle, the 4-1 standard, and the technical security requirement, builds the system subsystem components, which would include applications, embedded devices, network components, host devices. And these off-the-shelf products are then configured into site-specific solutions by the integrator. And that's operated at the top by the asset owner, and who has operational and maintenance capabilities, policies, procedures, et cetera. So in the big picture, we always discuss technology, people, and process, or people, process, and technology. And so when we're looking at risk reduction, in the technology, we're addressing security capabilities. And the process side, it's a maturity dimension, the maturity of deployment processes, operational and maintenance processes, and other policies and procedures if we're looking at it from the owner-operator perspective. And then personnel competency. So the 62443 standards are pretty well designed to address the technology and process dimensions, but there really aren't any standards yet for personnel competencies. So there are some separate standalone personnel measures like the CISSP and some other professional designations, but they're not codified into the 62443 standards at this time. So the ISASecure scheme, it's internationally accredited 17065 conformance scheme. And so that means that all the labs that are doing certifications on behalf of the ISASecure conformance scheme are independently assessed and accredited by 17011 accreditation bodies. So, for instance, ANSI A-Class or ANSI A-NAB accredited a lab based in the U.S. that has operations globally. EXA, the Japan Accreditation Board, accredited labs in a lab in Japan. The CSSC is a quasi-governmental lab, and DAX is a German accreditation authority, actually the only one in Germany, and they're accrediting a lab to be announced in a couple months. It's based in Germany. So the point was to provide global recognition and acceptance of the certifications through multilateral recognition arrangements. The certifications done by one lab in one geography are mutually recognized by the other labs participating in the multilateral recognition arrangements. So back to the ISASecure scheme, our focus is on the commercial off-the-shelf products. So today we're certifying the components and subsystems that go into the site engineered solutions that are eventually deployed. Today there's 3 certifications available. The first one that we launched was an Embedded Device Security Assurance Product Certification. This is intended to certify to the 4-2 standard, also using the Life Cycle 4-1 standard. And there's a System Security Assurance certification, so that's control systems that may be comprised of a controller and embedded devices, networks, network components such as routers and switches, and that certifies to the 3-3 standard. If you look at the components that are in the system, they would also need to meet the requirements of our embedded device security certification. So this encompasses pretty much all those standards. And then as an offshoot, we developed a Security Development Lifecycle Assurance certification. So it's a process certification for developer organizations. So, for instance, Schneider Electric is the world's first vendor to achieve the SDLA, and they did it at 3 different sites. So what this means is that they were, their development processes were independently assessed by an accredited lab and shown to use good security practices in each of the development phases. So we'll talk about the Embedded Device Security Assurance certification. What is it? So what's an embedded device? Special purpose device running embedded software designed to directly monitor, control, or actuate an industrial process. So PLCs, DCS, RTUs, etc., all fit in this. A lot of these devices here are what we would typically see in the oil and gas industry and traditional process industries, but the standard was, the 62443 standards were established as a technology horizontal, so it could be applicable to other industries such as building controls, utilities, water, wastewater, etc. So what do we do when we do an EDSA certification? Well, the independent lab provides certification that the product is robust against network attacks and free from known security vulnerabilities. It meets the requirements of the 62443 standards for embedded devices. And it's an independent certification of the product's security capabilities and security level as defined by the standard. So through the certification, owner-operators would include in procurement requirements the ISASecure level 1, 2, or 3, and look on the list of products that have that certification or require your suppliers to have this certification, and that mitigates the time and cost to do evaluations on a project-by-project basis. You have a known starting point for security capabilities. It reduces the need for staff or outside consultants to come in and do the security evaluations, et cetera. So the actual certification is comprised of 3 broad areas. There's security lifecycle assessment. So there's an audit of the security development lifecycle at the supplier. So you ensure that the software development and maintenance processes follow a robust development process and hopefully will detect and avoid systematic design faults. And there's a functional security assessment of the product, and that's there to look for implementation errors and also identify and measure and confirm the product's security capabilities. Then there's an actual test that's done. We do a communication robustness test, or I should say the labs do, and a vulnerability identification test. So the communication robustness test uses tools like Codenomicon Defensix, WorldTech, Achilles to do fuzzing, denial of service, and storms and that sort of thing to a specified level of abuse, fuzzing, et cetera. The vulnerability identification test is done with the Nessus tool from Tenable and scans the embedded device for known vulnerabilities, and it is run using the U.S. CERT National Vulnerability Database. So at the time the product is assessed, it's done against whatever that version is in place that day. And then the recommendation is that for products that are certified that asset owners are requiring in their site solutions, they may ask the supplier to run another Nessus scan, maybe at factory acceptance test or site acceptance test time. The system security assurance, it goes against the 3-3, 4-1, and 4-2 standards. And again, it's similar to the embedded device, but it's a system level. It's free from known security vulnerabilities and robust against network attacks. Meets the 62443 standards. And again, it's an independent certification of the product's security capabilities and security levels as defined in the standards. So what's a system? Seems pretty easy, but it was very difficult for us to come up with a definition. But in the end, their definition is it's an industrial control system or SCADA system. Comes from a single supplier, supported by a single supplier. So it could be a off-the-shelf system that's built by an integrator that they sell repeatedly that they want to have certified as a integrated system. So again, the components are in a single system. It may have multiple security zones, but in the end, it's identified by a product name and version, and it's typically sold repeatedly. It's an off-the-shelf system, again, not site engineered or project engineered yet. So this would go, certified system would provide the basis for a site engineered solution. So in this program, Similarly, we look at the security development lifecycle, ensure that security was designed in. We do a functional security assessment and identify and confirm functional security features that are available at the level 1, 2, 3. And also do system robustness testing. So we'll do unicast storms and broadcast storms on the network system. There's structured penetration testing and fuzzing at any entry points into the zones. And also there's a scan for vulnerability identification using the Nessus tool, and that's done at the system level. So servers and other generalized IT products, they're tested. So one of the questions that we typically get is, okay, you know, you're testing and certifying embedded devices and control systems, but what about the servers and the general IT products? So while we don't certify those, they are stressed as part of the testing process. So, and they're evaluated as part of the functional security, as quite often the systems will use layers of security, and you might use a domain for roles-based authorization and the like. So we will test switches, routers as part of the overall test, and to the extent that we can scan servers with the VIT, we do that as well. But we don't issue certificates for those components, not yet. So the security development lifecycle assurance, again, this is a process certification. The supplier's development organization is evaluated for security tasks that are done in each of the lifecycle phases, and they're certified for that. There's a periodic review of their lifecycle practices. After the initial certification, every 3 years, there's a revisit. Typically, if there's some type of change to their processes, there'll be a visit at that time, maybe once a year. So certification of product development sites have work process that include security considerations, and it's intended to meet the requirements of the 4-1 standard. And we were a bit ahead of the standard, and the SDLA cert was based on the Microsoft SDL. We used that as a basis for the life cycle phases, included requirements that were necessary for industrial control systems, and when that was completed, we had it reviewed. Microsoft, one of the Microsoft subject matter experts on SDL reviewed it and provided some input. But we defined 12 phases. Typically, suppliers may have something that's a little bit different in terms of the phase definition, but we would expect to see the activities that are included in these phases addressed somewhere in the supplier's SDL. So it goes through everything: the management process, requirements, architecture, detailed software design, what type of testing is done, the system testing integration, is there a static code analysis, binary and dynamic code analysis done as part of the process. We also look at their security response planning. So if there's an incident in the field, do they have programs in place to address that, provide patches or workarounds while software updates are being completed, and various other responses. Also, communication plans. So we're aligning the program with the 62443 standards that define 4 levels of security, and those 4 levels of security are really based on what the origin of the threat is. Is it like casual mishaps from internally developed issues, self-inflicted wounds, if you will, at one end, and at the extreme end of security level 4, this would be protecting against threats from organized, highly sophisticated attackers like nation states and like that. So what's the value? So if you're an owner-operator doing procurement, every owner-operator has their own approach for assessing risk for each of the applications and use cases, and based on your risk level, you determine whether you want a security level 1, 2, or 3 system. Today, most owner-operators at this time are requiring a level 1, and that's mainly because there are not too many systems that have been built to level 3 or 4 that are being assessed. But again, it's similar to SIL requirements. So if the asset owner reviews the certification requirements and note the security levels, you get a sense of which one you should be requiring in your procurement specs. And then you specify that in the COTS portion of the procurement document. And then if you have any company-specific or project-specific exceptions or additions, then that would complete your requirements. But the idea is to make it very much like SIL certifications. So you just specify ISASecure level 1, 2, or 3, or 4. The list of certified devices, there are more that are in the pipeline being certified today, but you can see there's certified devices from major suppliers including Honeywell, Yokogawa, Hitachi, Osbill, and Schneider. There's a list of the certified development organizations. So today, Schneider Electric, they were the first. They're really embracing cybersecurity in all their products. So they have 3 sites certified. There are additional supplier development organizations under assessment today, and as they're completed, they'll be announced and added to the list. These are all on the website, by the way. And so we also have a process for recognizing the test tools. This is to ensure that they meet the proper level of rigor and meet our testing requirements, and also to ensure consistent results from the testing from one lab to the next or one tool to the next. And this provides some guidance for supplier organizations if they're looking at test tools to include in their development processes and regression testing. If they use the same tools that the labs and the ISASecure scheme is using, they should have pretty good confidence that when their products are completed, that they're going to meet the security requirements and security capabilities in the different levels. There are other tools under evaluation for recognition. Again, those will be announced as they come out. So certification bodies, they're accredited independently by 17011 accreditation bodies. Today there's 2, Exida and the CSSC lab in Japan. There's an additional accreditation in progress in Germany from a major lab, and we'll announce that in a couple months when that's completed. And DAX is doing that accreditation process. So we've got some new work, a roadmap. A key item is an application security assurance certification. So this is to certify control systems and applications that are related to it that are software-based only. There are some SCADA systems that are software only that run on general purpose computers. There's historians, intrusion protection and detection systems, and many, many other applications. Earlier this year, we kicked off a working group to evaluate the certification scheme and the 62443 standards for applicability to building automation systems. This was a request that was done by suppliers in Japan, and the Japanese government made an edict similar to our government, but they wanted to have their building automation systems certified by the 2020 Olympics. So we're working on that, and we should have a report on that in a couple or 3 months. We're collaborating with the European Union. They have a study group, the ERNCIP. It's similar to NIST in the United States. They are standing up a conformity assessment program that looks a lot like ours, and so we're helping them out with that. And part of that goal there is to seek to harmonize what they're doing with what we're doing, so either they'll use our specs or we would establish harmonization agreements or equivalence agreements to make certifications economically efficient, such that suppliers don't have to do multiple certifications with differing pass-fail requirements from different geographies. And we're also, it's an ongoing project to expand the industrial protocol coverage for inclusion in the communication robustness testing. So to summarize why certify the COTS products, again, the security capabilities are independently assessed. Reduces the effort for end users to validate and verify the capabilities, and they're based on objective metrics. And those are the 62443 standards that have hundreds of years of subject matter expertise in them. So that's it. And at this time, let's see, we've got about 20 minutes or so. So we'll open it up to questions. Okay, so far no questions. So one question that we commonly get is if you do a certification on a system, say Q1 of 2016, the supplier changes the product, how do you know that the new product is going to maintain the certification? And so we have policies and procedures in place so that when products change, the supplier does a submittal to the certifying lab. The certifying lab will evaluate the changes, and based on the extent of the changes, it determine how much either retesting or reassessment needs to be done. And sometimes it's just updates to documentation that's unclear, but then the certification lab would issue a certificate for the updated version number. So there's a question, there used to be the WorldTech certification. What's happening with those? So, so the WorldTech is the Achilles certification. That is the communication robustness test. I think they're still doing those, but the certifications that we do include communication robustness testing, and so if you get an ISASecure certification for an embedded device, it will have been tested by a test appliance like Achilles or Codenomicon Defensix, but the WorldTech platform is used, it's recognized for our program, so I don't know what's going to happen with the WorldTech cert, but you know, it has some value, but as a certification, we view it more as a test. So it's a test that tests one dimension of what we're doing in our overall assessment, but it's not comprehensive enough to be what we consider a certification. Let's see. So the ISASecure program, it's available to anybody who wants to use it. So right now, today, if you're a supplier, you don't have to be a member. You don't have to be an ISA member. All you need to do is include ISASecure in your procurement specs, and that's it. So yeah, I mean, we seek new members. We're always expanding the program coverage, and so the membership fees that we receive, we operate like a consortia that contributes to the budget for expanding the protocol coverage, doing other types of certifications like the application security, et cetera. We're not for profit. We collect registration fees for the certifications which the suppliers pay. And so between the registration fees and the membership dues, that's where the funding comes from to operate the program and to expand the coverage. It's not static. As the standards change, we'll do updates every 3 years. Standards are opened up to maintenance, and so as those standards are maintained, we will follow behind it and update our certification requirements to align with the standards. So that's a normal part of what we do, but it does cost. So next question, assuming the COTS products are certified, how does that mesh when an integrator integrates an entire system by a system integrator? What certifications should the system integrator possess, and how do you certify the final integrated system? So those are three great questions. So first of all, the big value in having the COTS product certified is that you independently know what the security capabilities are based on the certification. So as an asset owner, you would want the system integrator to use those products. It provides a basis for determining if the COTS products have the capabilities to meet your security requirements. So you really don't want a starting position of using products that are lacking security capabilities that you then have to fix or button up during the integration process. That's where we are today. Products that have been developed and installed at operating sites, 10, 15, 20 years ago are typically deficient in security capabilities. So there was a lot of patching and putting in firewalls, et cetera, to try to make those systems more secure. But you end up with a brittle system. So systems change, so as the system changes, it's very difficult if the individual components don't have pretty good capabilities for protecting themselves. So if you fast forward 10 years down the road, the more security capability that's architected and engineered into the components will make it easier for integrators to select and assemble these into deployed systems. There is a certification. There's a 62443 2-4 standard. It's an integrator practices standard. That one was submitted directly to the IEC, and actually IEC is standing up a certification scheme that should become operational sometime in Q1 of 2017, and that's an integrator certification for integration practices. So like the Tier 1 suppliers who have a product group, and then they also have a professional services group that do integration and deployments. The professional services group would probably get the integrator certification. Certifying the final integrated system, we don't do that. That's something that would probably be done by an independent consultant. You might have a company like Exeter or Connexus or TUV may have professional services that do that, but like the safety world, there's a lot of companies that are doing these standalone certifications. But again, these are systems are living, breathing beasts, and so as they are changed and maintained over time, I would think that the owner-operators would have policies and procedures and practices for maintaining the security integrity of the deployed systems. Okay. One of the participants wanted to know if this was being recorded. The answer is yeah, this is available. We're going to post it up on the website. We have your email addresses, and so we'll send a thank you note to everybody for participating, and have links to the recorded webinar and the slide deck. Additional questions? I'll give it another minute. It's about going on 10 of. If I don't get additional questions, I'll give you your day back. Okay. So I'll go ahead and terminate the webinar. And again, thank you very much for showing up today. I hope this helped out some. If there are additional questions that you have as an afterthought, my contact information is on the last slide, probably on the first slide as well. Feel free to send me a note, and our folks will do what we can to help out. All right. Take care and have a great day.